Hello everyone, this is Ketish here. In this video, I'm going to go through question number 2 from the AQA 2022 Physics Paper 1 higher tier. This question is on the topic of atomic model of matter. Figure 2 shows a rock found by a student on a beach. To help identify the type of rock, the student took measurements to determine its density. 2.1. Describe a method the student could use to determine the density of the rock. Now, this question refers to one of the required practicals on finding the density of regular and irregular objects. Now, the rock is an irregular object, which means you cannot measure its length, width, and height to find its volume. Remember, density is mass divided by the volume. Now, in order to find the mass, you can use a weighing scale. In order to find the density, you will have to use either a Eureka can or a displacement can, a measuring cylinder, if the rock can actually fit into the measuring cylinder. So here's an example of what a Eureka can looks like, or you can also call it a displacement can. So you fill the can up to the water level. So when you pour in water, water will eventually come out of the spout. So you fill it up to the spout level. And then when you place the rock, the water level will go up, and the displaced water should be collected in a measuring cylinder, and you should be able to measure its volume. If you're using a measuring cylinder, here's an example of a diagram. So you would fill the measuring cylinder halfway up with water, record the volume, and then place the rock inside it and find out the difference in the volume of the water. So how do you write this? The answer for this question, for 6 marks, you could start off by saying use mass and volume to calculate the density. Density equals mass divided by the volume. Stating the equation gives you 1 mark definitely. And the second point, measure mass of rock using a balance or weighing scale. That gives you another mark. And you don't really have to write both methods. So if I was to use the measuring cylinder, part fill a measuring cylinder with water and measure the initial volume, place rock in water and measure the final volume. Volume of rock equals final volume minus the initial volume. Now, if you're describing how to use the displacement can, you would say fill a displacement can or Eureka can with water to spout level, place rock in water and collect displaced water in a measuring cylinder. Volume of rock equals volume of displaced water. Next part, the student determined the density of the rock to be 2.55 plus or minus 0.1 gram per centimeter cube. What are the minimum and maximum values of the rock for the density of the rock? So the maximum value, you would simply add 0.1 to 2.55. So if you add 0.1 to 2.55, it should be 2.65. That's the maximum value. And you take away 0.1 from 2.55, that would be 2.45. 2.3, the table 1 gives the density of 5 different types of rocks. Which type of rock in table 1 could be the type of rock the student had? So you have got 4 options, tick 1 box. Now, using the maximum and minimum value, basalt falls out of those value, out of that range. Now chalk, if I add 2.35 plus 0.15, that will give me 2.50, which falls in that minimum range. So it could be chalk. Flint, 2.6. If I take away 0.1 from that, that will be 2.50. 5 as well. That also falls under this, so it could be flint. Sandstone, if I add 0.2 to this, 2.4, that doesn't fall in that minimum range, so it could be flint and chalk. Yeah, so chalk or flint is the answer. Next part, 2.4. The student only took one set of measurements to determine the density of the rock. Explain why taking measurements more than once may improve the accuracy of the density value. Now, how can you improve the accuracy by taking more than one measurement? Now, if you take more than one measurement, let's say take 3 measurements and calculate a mean, right? So a mean can be calculated, which reduces the effect of random errors. Now, if you identify the errors, then it can be actually be removed. So anomalies can be identified and removed by taking more than one measurement. That brings us to the end of the question. It's important that you understand the difference between accuracy and precision. So here's a simple diagram to explain the difference. In this first one, you can say it's low accuracy and low precision. Here, it's high precision because all of the points are in one spot, but it's low accuracy. If you want to be accurate, you're trying to be getting it in the right in the middle. So that would be high accuracy and high precision. And this is high accuracy near the area, but low precision, it's not near each other. So the difference between accuracy and precision, here's a simple table to compare the difference. Accuracy is closeness with the true value of the quantity being measured, while precision is a measure of the reproducibility of the measurement. Measurement can be accurate but not necessarily precise. Measurement can be precise but not necessarily accurate. It can be determined with a single measurement. It needs several measurements to be determined if it's precise. Accuracy may be affected with systematic error. Precision may be affected with random error. Accuracy values have to be precise in most cases. Precise values may or may not be accurate. And there's a degree of conformity and degree of reproducibility. That brings us to the end of this video. I will see you in the next question.